Welcome to today's ArXiv CS Digest for April 27th, 2026. We received 682 new computer science papers today across 56 subfields. Let's dive into the top picks. Trend 1 of 5, Algorithms, Complexity, and Systems. This trend explores the fundamental limits of computation and system design through algorithmic analysis and complexity theory. This cluster covers 76 papers. Representative work includes exact structural abstraction and tractability limits, a strongly polynomial algorithm for Arctic auctions, and the optimal sample complexity of multi-class and list learning. Trend 2 of 5, Multimodal AI and Generation. These papers explore AI that integrates diverse data types for enhanced understanding and generative capabilities across various domains. This cluster covers 145 papers. Representative work includes World, R1, reinforcing 3D constraints for text-to-video generation. Tuna, 2, pixel embeddings beat vision encoders for multimodal understanding and generation, and Omni shotcut. Holistic relational shot boundary detection with shot query transformer. Trend 3 of 5, Scientific AI and Modeling. This trend focuses on using AI and modeling to understand, predict, and accelerate scientific phenomena and complex systems. This cluster covers 131 papers. Representative work includes symbolic recovery of PDEs from measurement data, Kolmogorov-Arnold energy models, fast, interpretable generative modeling, and conflict-aware harmonized rotational gradient for multi-scale kinetic regimes. Trend 4 of 5, AI for simulation and forecasting. AI agents are being developed and benchmarked to understand, predict, and optimize complex systems and real-world tasks. This cluster covers 160 papers. Representative work includes decoding the mechanisms of the hat-trick football manager game using Bayesian network structure learning, learning to think from multiple thinkers, and Varen, a configuration-driven BV simulation framework for subsystem-level studies. Trend 5 of 5, LLM control and evaluation. This trend focuses on developing methods and benchmarks to control and evaluate the behavior and performance of large language models. This cluster covers 170 papers. Representative work includes Magic TDS, fine-grained controllable speech synthesis with explicit local duration and pause control, personalized worked example generation from student code submissions using pattern-based knowledge components, and one token away from collapse. The fragility of instruction-tuned helpfulness. Up next, our first paper out of 5, High-Accuracy Sampling for Diffusion Models and Log-Concave Distributions by Fan Shun and Alexander Rachlin from MIT. Let's break down its key contributions. The paper introduces algorithms that achieve delta error sampling for diffusion models and polylogarithmic steps, an exponential improvement over prior methods. The work provides the first polylogarithmic complexity sampler for general log-concave distributions, requiring only gradient evaluations. The proposed algorithms achieve sampling complexity dependent on the intrinsic dimension of the data, offering further efficiency gains. Up next, our second paper out of 5, RetroInfer, a vector storage engine for scalable long-context LLM inference by Yaoqi Chun and Mao Yang from University of Science and Technology of China. Let's break down its key contributions. RetroInfer reconceptualizes the KV cache as a vector storage system, leveraging attention sparsity to accelerate long-context LLM inference. Introduces the wave index, an attention-aware vector index that efficiently retrieves critical tokens using approximation and estimation techniques. The wave buffer optimizes KV cache placement and overlaps computation with data transfer between GPU and CPU for sustained high throughput. Up next, our third paper out of 5, Learning Human Intention Priors from Large-Scale Human Demonstrations for Robotic Manipulation by Yifan Xie and Wenbo Ding from Tsinghua University. Let's break down its key contributions. Curated a large-scale dataset of 2.2 million robot manipulation episodes from heterogeneous human videos, enabling learning of human intention priors. Introduced a hierarchical vision-language action framework that factorizes manipulation into vision-language, intention, and fine control experts. Learned embodiment-agnostic 3D trajectories and latent human motion priors from hand-centric data, improving robot control under distribution shift. Up next, our fourth paper out of 5, Defusing the Trigger, plug-and-play defense for backdoored LLMs via tail risk intrinsic geometric smoothing by Kaixing Fan and Xuanju Tang from Harbin Institute of Technology. Let's break down its key contributions. TIGS is a novel defense mechanism that operates during inference without requiring parameter updates, clean data, or auxiliary generation, making it highly practical for deployment. The defense identifies backdoor triggers by detecting localized attention collapse and then applies intrinsic geometric smoothing to disrupt trigger-dominant routing while preserving semantic anchoring. TIGS demonstrates effectiveness across diverse LLM architectures with minimal latency overhead, achieving a favorable balance between security, utility, and performance. Up next, our fifth paper out of 5, Adaptive Distribution Randomized Neural Networks for PDEs, a low-dimensional distribution learning framework by Yu Yang and Fei Wang. Let's break down its key contributions. Introduces adaptive distribution randomized neural networks, ADRANN, that parameterize the hidden feature sampling distribution with a low-dimensional vector, optimizing this vector instead of all network weights. This preserves the least squares structure while reducing manual tuning. Employs a two-stage strategy, ridge-regularized reduced training for stable optimization of distribution parameters, followed by an unregularized least squares refit for accurate solution recovery. Develops PDE-driven adaptive distribution, PDD, and data-driven adaptive distribution, DE, mechanisms, and incorporates adaptive layer growth for localized structures, demonstrating broad applicability across different solver types. That's all for today's AR14 CS Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow.